The ICEVI, the Nippon Foundation Mathematics Package for Teachers video series, Abacus as a Mathematical Tool. Title of the video, Decimal Division. Example 175.6 divided by 2.3. In this problem, we have to convert both the dividend and the divisor into whole numbers. As the dividend as well as divisor have only a single decimal place each, both can be converted into whole numbers by multiplying them with 10, in which case the numbers become 1756 and 23. We had already mentioned that the adjustment in the decimal division is made in the numbers prior to the commencement of the division process and not after the division is over. We have already made the adjustment in this problem by converting both the numbers into whole numbers, and therefore we have to simply take the two whole numbers and carry out the division process. Let us set the dividend 1756 in the extreme right of the abacus, that is 1 in the thousands column, 7 in the hundreds column, 5 in the tens column, and 6 in the units column. Let us set the number 23, which is the divisor, on the left extreme of the abacus. As the highest digit of the dividend is 1, which is less than the highest digit of the divisor, which is 2, there is no need to skip a column in setting the quotient. That means the quotient should be set to the immediate left of the number 1. Now, let us consider the first digit of the dividend, which is smaller than the first digit of the divisor, and therefore we have to take the first two digits of the dividend, and in this case it is 17. Now ask how many 2's in 17? We get 8. As a general rule, let us reduce 1 from this 8 and set 7 to the immediate left of the dividend. Now let us multiply 7 with the divisor 23 and subtract it from the dividend. 7 multiplied by 2 is 14, and therefore we have to subtract 1 from the thousands column and 4 from the hundreds column. For doing this, we have to clear 5 in the upper abacus and add 1 in the lower abacus. Let us multiply 7 with 3, which is 21. That should be reduced from the dividend, that is 2 from the hundreds column and 1 from the tens column. In the tens column, we have to clear 5 in the upper abacus and add 4 in the lower abacus. Now we are left with 146 in the dividend. Now take the first two digits of the dividend, which is 14, by saying there are 7 2's in 14. Reduce 1 by applying the general rule and therefore set the number 6 as the second digit of the quotient, and it should be set to the right of the already set quotient 7. Now let us multiply 6 with 23. That is 6 multiplied by 2 is 12. That means we have to clear 1 bead in the hundreds column and then 2 from the tens column. In the next stage, we have to multiply 3 with 6, which gives 18, and therefore we have to reduce 1 from the tens column and 8 from the units column. We cannot reduce 8 from the units column, and therefore we clear one bead in the tens column, and in order to compensate that, we have to add 2 in the units column. Now we are left with 8 in the units column. 8 is less than 23, and therefore there is no adjustment necessary in the assumed quotient. In this case, our assumed quotient has become the real quotient, and in many cases this happens. Let us look at the result part. In any double-digit divisor, the possible remainder may also be a double-digit number, and therefore we should treat 2 right extreme columns as the places for remainder, and the one to the left of it is the column separating the quotient and the remainder. In this case, the column immediate to the left of the remainder indicates 0. That means the remainder is 0, 8. And the third column from the right is the one which is separating the quotient and the remainder. Therefore, the result in this problem is 76 as the quotient and 8 as the remainder. As we have to indicate the result in terms of decimal number 2, the remainder 8 can be converted into decimal by dividing the same by the divisor 23, and the value is approximately 0.35. Therefore, the result of this problem, when it is interpreted in terms of decimals, is 76.35.